Okay. So, are you familiar with a polypeptide chain?
No.
Okay, so a polypeptide chain is what makes up a protein.
Okay.
And the protein in a polypeptide chain is made up of amino acids.
Okay.
And there's 20 amino acids, okay? And
The
each one of
20 little
these
things.
each one of these represent an amino acid. So the purple ones represent a certain one, the green ones represent a certain one, these green ones, brown one, white ones, red, blue, orange, pink.
Okay.
Okay, so those all represent individual amino acids. They're sorted into the amino acids.
Okay.
And then, are you familiar with DNA and how that's made up? Okay. So.
Kind of.
So DNA is made up of a bunch of nucleotides. Okay. There's a bunch of nucleotides that are set up into a long chain that represents a code. Okay. So let me show you an example of a. That's the type of code that we're talking about. ATGCA. Okay. And we can shoot something right on.
And was this a quiz?
A little bit, sort of.
Oh.
It's not that hard.
Joe, there's paper. There's paper in the printer. Do you need a pen? There's a pen in my black bag there. On the island. On the island? Yeah. Alright.
So, are you familiar with how a DNA is structured?
No.
Okay, so it's a double helix. It looks like this. You've seen that before.
Oh yeah, I have.
So they're paired up. Each side, this side is paired up with this side. This side is paired up with this side, so on, right? Because A is always paired up with T, G is always paired up with C. Okay, this is adenine, this is thymine, this is glycine, this is cytosine. Okay, so like A would be over here and T would be over here. G would be over here, C. T, A. And then, so that goes on forever. And then that represents what proteins are made based on what the code is.
What if they're paired up wrong?
That's how a mutation is made. But generally, they can't be paired up wrong because A and T get paired up with 2 bonds, and G and C get paired up with 3. So they're usually just together that way, like down to like the chemical stuff. But that's complicated. So to go from the DNA to the amino acids, you have to go from the DNA down to RNA. RNA is fun. Okay, RNA is like, think about it as the messenger that messages the DNA to certain structures that make proteins. Okay. So the RNA, first of all, on RNA, it's a similar thing where A is paired up with T and G is C, except on RNA, T gets replaced with U. Which is just like this random thing that's super annoying and frustrates everybody. Okay, so this process from DNA to RNA is called transcription.
Alright.
Okay, transcription. So what happens is it takes, let's say, this strand of DNA as the template
Mm-hmm.
And so since this is T, this will be A. Since this is C, this will be G.
Mm-hmm.
Since this is A,
Mm-hmm.
this becomes U. Okay?
Mm-hmm.
And that's the RNA, and that goes down through a process called translation.
That was transcription. Oh, transcription is that one.
That's from DNA to RNA.
Yeah.
Then RNA to proteins.
Translation.
Translation. Okay? And based on what three nucleotides are next to each other, that makes one of these.
Okay.
That makes one amino acid.
What makes them green versus blue versus whatever? What makes them all different?
The chemical structure.
Okay.
So this 3-letter code determines the chemical structure of the amino acid, which sets it apart. And I'll tell you why this is important. Otherwise, this is useless and makes no sense. But it goes from amino acid to polypeptide chain to big squiggly protein, which is the reason that you have brown hair.
Oh.
So it's kind of cool. Other than that, it's just like, okay, why do I care? So
very cool.
Yeah, you're about to get really confused though. So here is. Let me pull it up real fast. Should I let him out?
Mm-hmm. With the light on.
Scale of 1 to 10, how confused are you so far?
Not very.
Alright, it's not bad.
Makes sense.
Yeah.
I'm just getting a tissue for my eyes.
Okay.
Not one, two. Done?
What?
Okay. Do I have to memorize all of this?
No.
Okay, here.
Okay.